Hello everyone, welcome back to the channel. Today, we're diving into one of NASA's most ambitious and fascinating aviation projects, the X-59 Quesst. The X-59 Quesst is one of the most ambitious aircraft projects ever undertaken by NASA, and it has the potential to completely transform the future of air travel. For decades, supersonic flight has been possible, but it has always come with one major drawback: the loud and disruptive sonic boom that occurs when an aircraft breaks the sound barrier. This noise is powerful enough to rattle windows, startle people on the ground, and even cause minor structural damage in some cases. Because of this, supersonic travel over land has been banned in many countries since the early 1970s. The X-59 aims to change that by replacing the deafening boom with a much softer sonic thump, a sound gentle enough that it could open the door for supersonic flights over populated areas without violating noise restrictions. This is not just a step forward in aviation, it's a complete reimagining of what supersonic travel can be. The aircraft's design is unlike anything seen in commercial or military aviation. Measuring about 99.7 feet in length, the X-59 has a long, needle-like nose that makes up nearly a third of its body. This feature is not just for aesthetics, it plays a critical role in shaping the shockwaves created during supersonic flight. Normally, shockwaves merge together into a single, powerful wave that causes the boom. The X-59's elongated nose ensures that these waves are spread out and broken into smaller ones before they hit the ground, reducing their intensity. The fuselage is narrow, optimized to reduce drag and maintain smooth airflow at high speeds. Its wings are slender and set low on the body, contributing to stability and efficiency during supersonic cruising. The tail section is elevated with a unique high-mounted horizontal stabilizer to further enhance aerodynamic performance. Every curve and angle has been calculated to manipulate air pressure in a way that minimizes noise without sacrificing speed or safety. Unlike most aircraft, the cockpit of the X-59 is positioned unusually far back from the nose. This design choice was necessary to achieve the desired aerodynamic shape, but it created a new challenge. Without a traditional forward-facing windshield, how would the pilot see ahead? NASA solved this problem by developing the External Vision System, or XVS. This system uses high-definition cameras mounted on the outside of the aircraft, feeding live video to large monitors in the cockpit. The pilot gets a clear, real-time view of the airspace ahead, with overlays that display crucial flight information. While the cockpit is not spacious, since the X-59 is a single-pilot test aircraft, it is highly advanced, with digital flight controls, ergonomic seating, and intuitive display layouts. This is not a plane built for passenger comfort, it's a precision instrument designed for groundbreaking research. Performance-wise, the X-59 is engineered to cruise at Mach 1.4, or roughly 925 miles per hour, at an altitude of about 55,000 feet. This puts it well above commercial airliner cruising heights, where thinner air allows for more efficient supersonic travel. Power comes from a single General Electric F414 engine, the same engine family used in advanced fighter jets like the F/A-18 Super Hornet. This engine provides enough thrust to maintain high speeds while being optimized for reduced noise output. The X-59's unique aerodynamic shape ensures that the shockwaves are carefully managed, and ground tests combined with computer simulations suggest that people on the surface will hear only a soft thump about as loud as a car door closing. If these predictions prove accurate during flight tests, it could be a turning point in aviation regulation, allowing the return of supersonic passenger travel without the environmental and noise concerns that ended it before. Safety is paramount in the X-59's design. Since it is an experimental aircraft, every system has been engineered with redundancy in mind. The flight control systems are backed up by multiple fail-safe mechanisms to ensure stability even in the event of a malfunction. The structure is built from advanced composite materials capable of withstanding extreme aerodynamic stresses. The external vision system not only serves as a replacement for the windshield but also integrates collision avoidance technology, ensuring that the pilot is always aware of surrounding air traffic. Sensors throughout the aircraft continuously monitor its condition in real time, feeding data to both the pilot and ground-based engineers. Emergency systems are also installed to handle any unforeseen issues during test flights. What makes the X-59 so unique is not just its quiet supersonic capability, but the potential ripple effect it could have on the entire aviation industry. By proving that supersonic travel can be made quiet enough for overland flights, NASA hopes to provide data that will influence regulators around the world to lift long-standing bans on supersonic passenger aircraft. This could pave the way for a new generation of commercial airliners capable of cutting travel times dramatically. Imagine flying from New York to Los Angeles in just over 2 hours without the legal and environmental issues that plagued earlier supersonic planes like the Concorde. In addition, the use of an external vision system instead of a windshield could inspire new designs for aircraft cockpits, potentially improving aerodynamics and safety in ways we haven't yet imagined. While the X-59 itself is not intended for commercial sale, the development cost is estimated at around $250 million. This figure reflects its role as a research and technology demonstrator rather than a mass-produced vehicle. The real value lies in the data it will collect. NASA plans to fly the X-59 over select communities to study public reaction to its sonic thump. The results will be shared with the Federal Aviation Administration and other global regulators to help shape future noise standards for supersonic travel. If successful, the lessons learned from the X-59 will guide aircraft manufacturers in creating viable, affordable, and quiet supersonic passenger planes for the market. The X-59 represents a rare moment in aviation where engineering innovation, regulatory change, and public interest all converge. It is a sleek, futuristic machine with a clear purpose: to make supersonic flight practical, sustainable, and socially acceptable. By solving the problem of the sonic boom, it addresses the biggest barrier to supersonic overland travel. Its design showcases how cutting-edge technology can be applied to reshape not only aircraft performance but also the rules that govern how and where they can operate. It stands as a bridge between the supersonic dreams of the past and the quieter, faster, more connected future we could soon experience. If the X-59 achieves its mission, it will be remembered not just as an experimental plane, but as the key that unlocked the next chapter in aviation history. It will prove that speed and environmental responsibility can go hand in hand, and that the barriers we once thought impossible to overcome can be broken with the right blend of vision, science, and determination. From its needle-shaped nose to its innovative vision system and groundbreaking acoustic engineering, the X-59 is a glimpse into a future where crossing continents in record time will be as routine as booking a normal flight today. This aircraft is not only pushing the limits of aerodynamics and noise control, it's pushing the limits of imagination itself.